Section 5.1 deals with differentiation of natural logarithmic functions. So some of you are going to have a little bit of trouble because we've been integrating for a while. We're going to go back now and pick up some of our transcendental functions. We're going to learn how to both differentiate and integrate those. So it will be a review of differentiation. We need to review logarithmic properties because I assume you know these. And so let's just be clear on what I already assume there. The natural log of 1 equals 0, yeah, because e to the 0 would be 1. Remember that the natural log has a base of e. Then the natural log of two things multiplied can be split into two separate logs added. That's called expansion of logs. You can expand them, yes? Okay. And then if you have the natural log of something to a power, right here for property 3, remember that the power after the log can be brought to the front and becomes the coefficient of the log. And then if you have the natural log of two things divided, that splits into subtraction. So 1 log of a divided by b is equal to two separate logs. The one on top will be positive and the one on bottom will always have the minus sign in front of it. And finally, the natural log of e equals 1. So those are the properties that you need to be really familiar with in order to differentiate natural logs. Those properties are going to be really useful when we start differentiating natural logs, because if you take a look at this example, y equals the natural log of the quantity x cubed multiplied by the square root of x plus 2 all divided by the 4th root of x minus 3. It's going to be much easier to split that up into several different logs and take the derivative of it than it is to treat it as a whole, because that would involve the product rule and the quotient rule and the chain rule. So that would just be a nightmare. But we're going to use expansion to split it into separate logs, added and subtracted, and it's going to make it a lot easier for us when we're differentiating. So before we actually learn to differentiate, let's make sure that you're comfortable using those properties to expand this out. And when we say expand, we mean expand it as far as you possibly can. Break it into as many separate logs as you can. So if you look at this one, it will go into how many logs? 2 or 3? 3, yeah. These right here will split into 2, and this one will split it into a third. So we're going to do that first. We're going to expand it into the natural log of x cubed plus the natural log of x plus 2 to the 1/2 power. And you are going to want to rewrite your radicals as exponents, just like we do in pretty much all of calculus. And then those two are multiplied, but this guy is being divided by both of them, so we're going to subtract the natural log of x minus 3 to the 1/4 power. So we're going to change our radicals into exponential form. We're going to expand as far as we can. Anything on top will be a positive log, and anything on bottom will always be a negative log. The final step is to apply the power property and bring your exponents down and make them coefficients. So this would be 3 natural log of x plus 1/2 the natural log of x plus 2 minus 1/4 the natural log of x minus 3. And that is what we mean when we say fully expanded. Split it using addition and subtraction, and then rewrite your exponents as coefficients. So I'll let you guys try the second one. And technically, I didn't put it there, but really, there is an understood parentheses right there. Both of those things are attached to the natural log. So if we expand this guy as far as we can, did you get 2 natural log of x plus 4 natural log of 3x plus 5?
Yes.
And that is as far as it goes. And that is expansion of logarithms.